Hello. Good to be back. Apologies for radio silence. We've been doing other things, specifically with interviewing IO, but I did not forget about this meetup, and we should do it more often. We actually had a few of the record events over the course of several months. We even recorded two. One is released as unlisted, one is not released. So yeah, hopefully we can do it more often. In search for more topics, we found this one, which is now titled Benchmarking Production Systems. Apparently and evidently, I have some experience, both first principles wise and hands-on, so that should be fun. Let's do it. Much like the previous episode that was semi-released as unlisted. You can find the link if you want. It's called When Wrong Makes Right, when it's justifiable to go against the best practices in order to get things done. So that episode is probably the most useful episode for the mere mortals who are trying to apply the knowledge from this series in their daily lives. I hope that because that one kind of gives you the indulgence to fight against bad management practices, and I pretty much tell you guys explicitly how to argue against best practices, and in particular cases which techniques can be used. And I just pretty much tell you guys up front, feel free to reach out in our Slack or to me, and I'll help you defend your case. I hope this one would be about as good, in the sense that I will be talking about some real life things that are semi-contradictory to what people think is the correct course of action. So that must be fun. What we are doing today. I'm going to introduce the idea of performance testing. To be honest, I'm going to use the terms interchangeably. Benchmarking, load testing, performance testing. I think in practice there are subtle differences. I think benchmarking is more applicable to like super low level stuff, like benchmarking in particular for loop, for example. And load and performance testing are slightly different things, but I guess if you are in this space, you certainly do know the difference pretty well, better than me. And if you're not, it's cool to know that they are mostly interchangeable. So I will outline some basic ideas. I'll outline some principles that, in my experience, come to mind first for most people when it comes to doing performance testing. Then for basic principles and basic ideas, I will pretty much explain why some or most of them are wrong, as it always happens. Then I'll talk about how to best frame the problem to actually solve it. We'll talk about how to postulate it top-down from the goals to the solution. I will argue when to not do benchmarking, contrary to popular vision. And then I have some advice to aspiring engineers on how to apply this moving on in their careers. So common pitfalls. First of all, you can benchmark a system using a bash script. You can send 1,000 curl HTTP requests. You can collect the results and see if they are identical. That's pretty much the script. That's the line you do. That's the line you can run, which will do exactly what you think it will. Well, I cannot emphasize this enough. Please do not do this. That's just a bad way to test production systems. If your system does one request per 2 seconds, that's probably okay. But if you're anywhere near high performance, the overhead is just too large and too unpredictable. So it's a bad way. I'm guilty, I've done it myself. You could in theory write a bash script that would use multiple cores and start multiple processes that would do the same thing, like this particular thing, in parallel. My advice holds, do not do that. So the second obvious thing is it's tempting to run the system under test. It's commonly referred to as SUT. So if I say SUT, or if you see it in the slides, it's system under test. What is being tested? So one of the popular instincts is to run the system on the same machine on which you run the tester itself. This is actually not a bad idea. This is realistically a good idea in many cases, especially if you want to compare is apples to apples. Let's say you're making a change. You'd like to compare the performance of your system before and after your commit. By all means, apples to apples, use the same machine. Or if you need to make the build or buy decision, you have your own hacky code as a prototype, and you have some existing solution that you need to decide on whether you need to use it, you will use it, or you will not use it. That's also okay. So it's just if you decide to run the test on the same machine where you run the system under test, you need to justify it carefully. Realistically, the biggest issue, of course, is that your test by itself consumes resources. So you're going to interfere with the performance of the system under test with your own test. And quite often, if the system is lightweight, I've seen it a lot of times, the tester could literally use 2-3 times more resources than the system under test. If you're benchmarking a high performance key value storage, for example, it's not difficult to imagine a situation where you have like an 8-core machine and 6 cores are used for your test and 1.5 cores are used for the system under test. So if that's your scenario, that's super easy to test. Just call the top command or htop on Linux or BSD, or use the task manager for Windows. If you see the CPU utilization for the system under test is a bit too low and your test is eating a bit too much, chances are you're doing something wrong. If you do end up in this situation, at the least, the easiest thing you can do, you can limit the system under test in CPU, in resources. For example, if it's a Golang system, Gomax procs, Go maximum processors, is a good variable. You can drop it into a Docker container, give it a limited CPU, or even other constraints. That's okay too. Just keep in mind that you will interfere with the system. The second bullet point here is that not only you interfere with the system under test with your tester, a bunch of things are different if it's the same machine versus multiple machines, most notably the network. So it's a long topic, and I'm not qualified to talk about this in detail, but fundamentally, the loopback network interface is super fast, and it supports huge frames by design. So you can literally pump gigabytes of data per second over the loopback interface, and that's going to work. The network interface for real, it can also be super fast. It can also handle gigabytes per second, but it's a traffic of different nature, different mechanics kicking. So if it's let's say a streaming gRPC connection with buffering turned on, chances are you can utilize this whole 1 gigabyte for even more than 1 gigabyte per second, and you'll be fine. But if it's a service mesh, if it's a bunch of smaller packets, if it's unary requests, just the overhead to establish a connection, they will be larger than you would imagine, and the numbers would be different. The next common pitfall is some systems need to be warmed up before they perform at their performance, before they can give you the numbers you need to see in production. This mostly, in my experience, applies to JVM. For Java virtual machine applications, that is true for all JVMs. So Java, Kotlin, Clojure, imagine your own favorite JVM language. This thing can literally take seconds to warm up. I have seen systems where the actual performance is in the order of 1,000 queries per second, but for the first 2 or 3 seconds, it literally grows from 5 and 10 per second to maybe 25, 30. So of course, if you start the same service and run the test twice, for the second run you get the proper number. If the first one is at least a couple seconds, but it's remarkably slow to warm up. I'm still terrified by the idea that people use cloud autoscaling for JVM systems, but that's beyond today's conversation. The bottom line is, yeah, in my test, for example, what I do is if the test has multiple measurements, I run them up and down. So if the test runs, let's say 100 measurements, 1 second each, you can run them in one direction and then backwards. And then I can clearly see that the first few are too slow, which is perfectly fine. You can discount for that. Yeah. I'm going to have 5 slides on common pitfalls, surprisingly. So I even assigned numbers to them. So the next point is try not to evaluate performance on the same input query or on the same input stream. Basically, if you send the same query multiple times, chances are your system would somehow perform better than on different queries. There are multiple reasons for this, and it's not always noticeable. But trust me, if you want to have proper results, that's really not the best idea. Like realistically, if you have, in this example, it's like four A's, 4 A's, 4 B's, 4 C's, 4 D's. Imagine each of them is not 4 requests, but maybe 5 seconds worth of requests, which would be thousands, if not tens of thousands. If you send 5 seconds of A's followed by 5 seconds of B's, 5 seconds of C's, 5 seconds of D's, chances are it's going to be faster than if you send A, B, C, D in randomly shuffled order for the whole 20 seconds. This would happen because there are some hidden optimizations taking place outside your control. How bad it is, it depends on the level at which these optimizations kick in. If it's super low level stuff, if you're benchmarking literally single functions in your application, you could even hit CPU caching levels. You know that the same mechanics that if you have a 2D array, if you want to traverse it, you write two nested for loops. If you iterate over the outer index first and then the inner index, you get one performance. If you flip the for loops, if you don't go ij but go ji, you get far lower performance because the CPU cache pages are invalidated, so it has to go to the memory. Something like this may well happen. Branch prediction can make the correct assumption about what ifs would more likely trigger and what path would not be followed for a particular query, in this case A or B. So you would most likely not be affected by this if it's a large scale system, but just do keep in mind that these artifacts, you could hit them even when you're benchmarking your own non-trivial system. That's okay as in not too bad. The bad thing is that if the same principle applies to the just-in-time JIT compiler, most notably the JVM itself. So again, much like you need to warm up the JVM, it can, speaking in machine learning terms, it can overfit. It can see that certain for loops and certain if statements go one way more often than the other. And if it happens over a couple seconds straight, it can optimize your code on the fly to be fast for this path specifically. So that if you run the test for A for 10 seconds straight, starting second 4, 5, 6, or whatnot, this A query becomes much faster. And then once you go to B, it's slow again. So that's another reason why you need to randomize your queries. And of course, it's going to be very bad if this issue, like caching, happens across components, across modules. If you're testing a system of multiple components, one of which has some least recently used cache for the past, 10 queries, or for the past 1 megabyte, chances are the proper test would not use this cache or have some reasonably low cache hit rate, whereas running the same query multiple times would pretty much always result in the cache being hit. So just the bottom line, do not run the test over the same query. In fact, don't even run on the same query stream, because the same principle of JVM overfitting, overly optimizing for this particular set of queries, this risk is still there. Side note, that's why I'm not a fan of tools such as GHZ or Apache Bench or K6. They are nice to use, they give you pretty graphs, they let you configure load more or less the way you prefer, but to me they optimize for the wrong thing. They optimize for being able to run some tests quickly, so they just glorified shell scripting level testing. They solve a couple entry-level problems, but they don't really give you the proper picture of what's going on in your system. If you need to load test your system, and I'll talk about this later today. If you need to load test your system for real, because there's a business need to do that, chances are you probably want something more sophisticated than Apache Bench. Yeah, this bullet point sort of follows from the previous one. It's not just about the same input query, the same input stream. It's about the nature it's about the principle through which the input is received by the system. A trivial example here is if your system can support both streaming requests and unary requests. I borrow the terms from gRPC. Many systems these days are gRPC powered, but it can be anything. So realistically, when you're an engineer who builds some system and you decide to load test it, you sort of want to show good numbers. You're going to have this unconscious bias to show good numbers. So most likely you would say, hey, my code, I wrote this code, right? It's my code, I'm proud of it. My code can handle this many thousands of queries per second. And to prove this, I'm going to demonstrate one way that makes sure this number is attained, this number is achieved. And this way may or may not, more likely not, be the way through which the production service would receive these queries. In the extreme case, you have a streaming interface and you have unary interface, and you would say, hey, look, I can handle 10K queries per second through the streaming interface if I use 24 cores. And if some queries would be unary, like one-offs, well, even if they're 10 times slower, the majority of traffic I would receive from the streaming channel, so I'm good. And then you get a pleasant or unpleasant surprise that even if a small fraction of your queries are coming as unary requests, they affect the performance of your stream of requests, because there are so many ways it can possibly happen, because of lock-in, because of contention, because of internal fighting for resources. So a lot of things may happen. The bottom line is, if your system supports multiple means to receive inputs, try to make sure you test all of them, or at least that you try to make sure you test on the nature of inputs that is plausibly resembling future production usage. I also added a few bullet points here with respect to multi-threading. So for example, you could say, I know I'm going to open 4 streams, and I know my pod, if it's Kubernetes, will have 4 CPU cores. Well, yes, I don't disagree with that. That's how you get peak performance. But how often in production would you have an input data provider that would utilize 4 streams to its maximum capacity each? Most likely one of them would be super fast and the others would just be dragging around. So you literally get 4 times lower performance, close to 4 times lower performance. So the point is, if you are the developer who writes the code and you want to show off, that's how you do it. But if you're industry savvy business person who wants to ship a production service that would be lasting forever, or at least years and years, the numbers you will get and the way to get these numbers is different from just showing off. Next one is multiple components. If your system under test contains multiple components, you sort of have to assume the worst of each of them, because the happy path is now far less likely to be happy in production. If it's just one service with no dependencies, you just compute a couple things. If your service just checks if a given number is a prime number, then yeah, you just test your service. If your service goes to the database, publishes to some message queue, uses Redis, pretty much anything it could do, you will be surprised how many weird and unpredictable failure modes your dependencies may have. The worst offenders are databases and message queue. So you can test something with a database that is yours because you mock it, and you get amazing results. And these results may have nothing to do with production numbers, because this database is used by some other system in some other way that you may think does not interfere with your way, but it actually does. Sometimes you can fix it by configuring the database properly. Sometimes you cannot. Bottom line is, things will happen, so do assume the worst. If you, for example, publish to Kafka as part of your business logic, you would imagine publishing to Kafka is an instant order of one operation, and you'll be surprised that it's not always the case. If your Kafka cluster is overloaded, if it's being scaled right now, if it's adding partitions, if there are multiple consumer groups so that the orchestrator is busy, it can be slow for reasons outside your control. Cassandra, I was surprised recently to learn that Cassandra is super fast to write, but it's slow for reads because it's doing this thing called data repair during reads. So it would realize that the data is under-replicated and try to fix it during reads. So you would imagine that reads don't affect writes, but actually they do. With Cassandra, it happens in a particularly bad way. That's kind of sad, really. If you have a read-write path, intuitively you would think that adding a reading replica, let's say if it's a database, adding a database replica, if it's a Kafka topic or Rabbit, adding a subscriber or consumer or whatnot, you would assume it's not going to affect the write path, and you'll be surprised. So you kind of have to test for the worst scenarios, ideally resembling production. Ideally, you test in production, or at least in staging. So testing in production is actually not a bad idea. If you have the privilege to run your code on small fraction of traffic, let's say 1%, at least test on staging where you can somehow emulate production traffic to a certain degree. This has tons of benefits. And the last slide in this common pitfalls theme is know what you are measuring. Because a lot of people, I would say most people, when I talk to them about load testing, the first thing that comes to mind for them is, I need to know how many queries per second can my service handle. Much like I'm going to use the terms load and performance testing interchangeably, I'm going to use the terms QPS and RPS interchangeably. I personally always say QPS. People seem to converge on RPS these days. So I'm going to try to say RPS, requests per second. But if I say queries per second, that's the same thing. So a lot of people, their first instinct would be, hey, to load test my service, it's pretty much to measure how many queries per second can this service handle. And that is true for a very narrow niche set of use cases. And this is just not true if you're load testing for production. Because in practice, a couple major things come up. One is throughput is usually not that important. What's important is a combination of throughput and latency. Throughput is something you can easily buy in most cases. You can buy a more expensive machine, you can scale horizontally. That's usually not the problem. Latency is something that is far more difficult to buy. You cannot just pay money and have a 10 gigahertz CPU. They don't exist. So if your business is latency sensitive, making sure you handle the latency, making sure your service not only gives decent throughput, but also handles latency requirements, that's usually far more difficult than measuring throughput itself. Realistically, once you're at certain, so at some point, we engineers, we will measure the peak QPS just for ourselves. But realistically, somewhere around 90%-ish or 95%-ish of peak QPS, your latency will begin to deteriorate, especially at high percentiles. High percentile latency is usually 99th percentile or 99.9th percentile. So if your median latency is, let's say, 10 milliseconds, 15 milliseconds. If your P99 is 500 milliseconds, that's a terrible service. For every 100th request, the user will have to wait another half a second. And then if the end user request, let's say it's a large service such as Facebook, there are a bunch of services behind the scenes. When the user wants to load Facebook, I would say the number of services this request ultimately hits, it's in the dozens. You need to hit feed generator, avatars, comments sections, notifications, block lists or whatnot, messages. So if each of these services has a P99 latency of 500 milliseconds, the chances for the user to actually receive a complete page within under half a second is remarkably low, because at least one of the services would time out more or less at high percentile latency. So realistically, at the very least, like level 0 takeaway from this episode is, at the very least, at some point you would know your peak QPS. At peak QPS and near it, do measure latency, and then start going down slowly, because chances are in production, not only you will want to, you'll be instructed to run your service at somewhat around 70% of your peak QPS, specifically so that you have reserves, and specifically so that your latency is still manageable. I personally was quite surprised. And if you run the tests, if you write the test correctly, I usually write my own load tests. Maybe there are tools for that. I'm not aware of them. But if you have a properly built tool, you can literally draw the plot between queries per second and P99 latency, and you'll be surprised how does this chart look like. You lower the QPS a little bit, the latency goes down dramatically. Especially if you lower the QPS from like 99% of your peak QPS to 97% and then to 95%. And that's any reasonable SRE in any reasonable company would ask you for these numbers. They wouldn't care about your peak performance. They would say, fine, you have 20 machines or 23. We don't care. That's a negligible cost. We care about high percentile latency, and can you guarantee it's going to stay below a certain number? And what if there's a spike? What if you're a startup? That's always more fun of an example. If you're a startup and the link to your service is now published on Hacker News and you're on the first page, I think it's called the Slashdot effect. If this happens, you probably will die, and that's okay if you're a startup. But how exactly would you die? Would you die to the degree that your whole service requires full redeployment in manual mode, or will you just be slow-ish for the next 3 hours? That's the difference. That's the important part. All right. The first part is done. Now let's talk about the right framing of the problem of load testing. So first, some obvious things. Use production setup. Use the setup that you will use in production. Ideally, so depending on how mature your setup is, you may or may not have all of this. But honestly, in my experience, these days with GitHub Actions, with Dockerized builds, it's really not hard to have reproducible steps for all of these. So you can have the same binary built through the same pipeline. If you can deploy from every commit with a single click, you probably can extract the binary for every commit in a single click. That's the binary that goes to performance testing. That should be trivial. Next step, if your production system is containerized, maybe it's under Kubernetes or whatnot, maybe it's under some Terraform, AWS, you may want to configure your load testing setup to use the same topology in the same deployment setting. If you have a service mesh, if you have virtual private clouds, if you encrypt your traffic, ideally employ that too. Have a properly sandboxed setup just to load test your system as if it's running in production. Measure of traffic, I spoke about this before. One of good standard tests is what is called replay the last week's logs. That's actually an awesome test because it's guaranteed to be the same traffic as you would receive in production. Don't just take the last week, because week over week does change. If you are mature enough, if your company and your product is mature enough, your SRE team, your DevOps will probably have some week, 10 weeks ago, stored somewhere in S3. So you know for a fact you have this golden set of queries, which you can use to load test your system. That's normal. That's healthy. I endorse it. And of course, before you start claiming that you need to run performance testing of your service, you guys need to agree with a broader team what exactly is being measured. I mentioned this briefly before. So the bottom line, it will not be PQPS. It would have to do at least with latencies in addition to throughput. And there's more to that. Let's dive into it. I will now talk about the goals of benchmarking, of performance testing. And disclaimer, these I might use. I thought of this episode for a couple of weeks. So these are top 3 priorities that I have, but it's just me thinking out loud. This may be not the right framing. This is not something I can guarantee is correct. It's just how I view this. And I don't represent any company or whoever. It's just me thinking out loud. So from the engineering perspective, I think somewhat loosely in the order of importance, you would have 3 major goals when you plan for performance testing. Number 1 is stability. In order to justify a certain amount of engineering resources spent to doing performance testing, I need to have enough evidence that after we do that, our ultimate solution that we ship to production is going to be more stable. Number 2 is capacity planning, provisioning, and cost optimization. So at some point, you would need to figure out how many machines to allocate for a particular service. You would need to figure out how much would this cost. You would need to figure out if it goes over this number, how do you quickly scale up? Or if it goes down, how do you safely scale this down? If you don't have answers to these questions, and if it's a non-trivial amount of money, it may be justifiable to take out a week or 2 of the team's development cycles to actually run a simple load test and get some reference points. And number 3 is architectural considerations. That's what would affect the whole company's, the whole engineering team's priorities moving forward. So in the critical parts of infrastructure, in the critical parts of services, load testing can help highlight which parts are going to be bottlenecks in the near future and which parts should already be in the middle of refactoring because they cannot last the projected traffic growth in the next. So let's say some component requires 3 quarters to refactor, and we know for a fact that in 2 quarters we're going to hit the ceiling of the numbers this service can handle. So either you already are refactoring this service starting at least a quarter ago, or you're too late. So making these decisions early on and correctly certainly justifies doing a lot of extensive load testing. So for stability, the biggest point here is that if I put on my hat of the SRE, if I'm the person who's going to be running your service in production, I would certainly argue that you need a buffer to the provisioned capacity. It's just, I'm not happy if you claim that you expect 3K RPS traffic, your one node can handle 1K RPS, so I'm going to put 3 nodes and be happy. Like, just no, that's not how things work. You probably want to use multiple machines. You need to make sure at least one, more likely 2 of them failing does not affect production, as in you should be able to handle projected load with any 2 machines failing. That's a more or less standard practice in large companies. And as we talked about before, each of your boxes should most certainly not run at 100% of their peak capacity. The real number, the actual number, we're going to decide together with you if I'm the SRE. If I'm the SRE taking your project for support, I will be talking to you for many, many hours. What's the sweet spot of the optimal peak throughput? Which percentage of the peak throughput should we aim at in production? And of course, latency, especially peak latency, especially tail latency, will be one of the factors to consider. Another huge factor to consider would be how easy is it to fix your solution if it fails. The solution that is more expensive but trivial to fix is often better than a solution that is super nice, super optimized, but if it fails, hell breaks loose. So that's the pretty much top three things I will be talking to you about if I'm the SRE taking your service over. And then ideally, if your service is not something minor niche, if it's potentially something the company depends on, it's going to be up to the architects to define which metrics, what's the SLA and SLO, service level agreement, service level objective. What are the SLA and the SLO that your service should conform to? And this is going to be one of the biggest takeaways from these slides. The first one, more like level 0, was it's not always about peak RPS. The next important one is that's something many people miss. So it's worth stopping and thinking about slowly. In production, it's actually a very good idea to design the system in a way that keeps your node safe. So if we know that the best capacity, the best throughput for you is a certain number, let's say your peak RPS is 1K per node, and let's say we agreed to run at 75% of that. So we know that for 75%, for 750 requests per second, your service does a good job with respect to latency and stuff. I would try to configure my load balancers and gateways and whatnot to not give your nodes more traffic. That's part of the job of me configuring the cloud front end for you. And let's say I fail. Let's say somehow the traffic numbers went up. And let's say my limits did not work, and your service suddenly receives more than this amount of queries per second. In fact, as an SRE, I would be happy if your service itself would refuse to serve that. That's the key point. A lot of people miss it. If we agreed that your service should handle 750 RPS, if suddenly you receive more than 800, which is super easy to check, just return a 500 as in HTTP 500. Service to be easier. Most protocols have something like that. You can return gRPCs. You can return a standard gRPC response code. That is, I'm too busy, try again. HTTP 500 is good enough. For any other protocol, you can come up with a way that is not discarding the request, not trying its best to serve it, but explicitly responding with, I'm too busy. I'm not gonna answer this request. This is actually better because some users would probably need to refresh the page. Some users would not have part of the site load. That's okay because the result, that's the loss for us. But the win we get for sacrificing this is that the service is still up and running. It doesn't require manual intervention. It doesn't result in cascading failures. That is perfectly fine. In fact, limiting by RPS is actually not the most interesting thingy. The most interesting thing is limited by CPU utilization and by memory utilization. If somehow the requests became larger, during our process of me as an SRE accepting your service for production support, not only we agree that we should be sending you at most 750 queries per second of traffic, we would also agree that at no point in time, you should use more than, let's say, 80% of memory. That's part of the agreement we have. And it's probably going to be, we can later decide who owns this part. It can be on the CloudWatch, on the SRE level, it can be on the code level. But if it's on you, it's perfectly fine for your application to monitor how much memory does it use. If you use your own memory manager, which is a good idea, because garbage collection sucks. If you have your own memory manager, you know for a fact at any point in time how much RAM do you need. And you could just say, hey, we agreed I should not use more than 80%. I'm at 81%. You declare yourself partially unhealthy, and you tell the load balancer to send you less traffic until you, quote unquote, recover, as in go down something, go below a certain fraction. It's okay if it runs like this for half a day until the business day for the engineers begins, and you guys look into that and fix it together. Then we can renegotiate the agreement. It's far better for these alerts to be email alerts, for which we have days and weeks to react, as opposed to them being paging alerts because something is down and you have to wake up at night. That's the proper approach. So I cannot stress this enough. In production, you will be extremely far from the mode of trying to show peak RPS. Not only we will limit you at a certain number that is below your peak, we also explicitly encourage you to not even try to go above this number. We explicitly ask you to fail in a clean way, to refuse to serve part of the traffic, fraction of the traffic. That's how large-scale systems run, and that's how they should run, more or less. Of course, this does not apply to startups, at least early-stage startups. But if you look at Google, Microsoft, Netflix, that's most likely what they have for more critical services, and that's why they don't fail too often. All right, bullet point number 2 or 3, provisioning. That is actually super simple. You just do some estimates. So first of all, provisioning by itself does not require load testing. You can make back-of-the-envelope calculations and say I'm going to need 20 boxes. And if it's not too expensive for the company, we just give it 20 boxes. That's okay. If it's more expensive for the company, you may want to justify the ask. Or what is more likely, you may need to justify that, hey, if we run it as is, if you ship the current Node.js code, we're going to require 100 boxes, which is going to cost the company an extra 17 grand a month. So that's a good argument to actually implement parts of your service in Rust, for example. And in order to make this argument, you need performance testing. That's one of the really, really good reasons to do performance testing. In practice, yeah, if you have some numbers, plus like give or take, plus minus 50%, you can just say, hey, I need this many boxes. Scaling down is cheaper than scaling up. And if the service is particularly juicy, chances are you will experience a load spike on the first day when you announce it. So it's okay to over-provision. That's fine. 3 days later, we can shut down half the machines. That's okay. The tricky part is if your service can bring some other service you depend on to be near or over capacity. But that's not provisioning. That's my third bullet point, architecture. But if it happens, first of all, we ask, why the hell did we not catch it before? Then we ask, is it manageable? How bad is it? Can we avoid the disaster and still launch? What if somehow can you temporarily implement parts of your logic to depend on that service less? So that service may be slower. You may need to cut your traffic going in that direction, let's say by a factor of 5. Let's say you cache some of the results from the database on your site for 15 seconds. Even if it might be wrong, if it helps you launch and the service is critical, that's an okay decision. In most cases, it would be okay. And yeah, that's pretty much where we enter the territory of architecture. I'm trying to highlight that for this kind of use cases, proactively advocating for performance testing to justify that, hey, we need to put, based on our numbers, not just in theory, but in practice. Once we have the proper test setup, we know that, for example, that Kafka topic is going to go 3x. We just learned that. Do we know that this is okay for the larger system? If you cannot get this number correctly, if you cannot estimate it safely without doing load testing, do load testing. That's a good enough reason. And for the architectural part, that's, to be honest, the most interesting part for me. That's what I pretty much do daily, and that's what I think is the most juicy, the most rewarding part of the software engineer's career. So for the architectural benefits of load testing, if the load test is done correctly, we learn a lot more things. We learn of possible failure modes. And if we do have a good load test, we can break the service on purpose, and we can see how does it look like when it breaks. What happens? Does it segfault? Is it becoming too slow? Is it going out of memory because some internal queues are overflowing? That's what we need to monitor. That's what would be in Prometheus and alerts. That's what we're going to be paged about in production. All this would be shown if a proper load test is run. We can do what I call sensitivity analysis, as in if your service depends on 5 other services, maybe 4 of them can go down and it's still okay, but 1 of 5 is critical, and we should absolutely not allow that to go down. We need to know this for a fact. So in most cases, you can actually justify this just from the architectural diagram. You don't need to run the test. But sometimes you'll be surprised that certain service is more loaded than others because you make more requests to that than you anticipated for certain queries pattern. All this happens. If it's like something like GraphQL, you'll never know how many SQL queries would each GraphQL query translate to, and then suddenly you realize ideally before production, during load testing phase. That's a good way to justify load test, because we cannot guarantee that this SQL database will not be loaded 10x more once we launch this. That's what I call sensitivity analysis. You can look for bottlenecks, and you can proactively think of ways to mitigate that. If I add more CPU, well, if I use bigger pods, or if I add more RAM, is it helpful at all, or am I hitting the boundary in different spaces? So beefier machines do not help me. If I were to scale, yeah, I need to know what my obstacles are. Sometimes I just know for a fact I can scale as much as I want. But people talk about horizontal scaling all the time, as in you can provision 10 times more machines and get 10 times the throughput. In reality, that's almost never the case. In reality, most designs have a hard limit after which adding machines does not make it faster. And as an architect, I'd like to know how far that limit is. In most cases, it's pretty far, but at times, Ref Cassandra as an example, at times things get tricky. Also, my favorite part, last bullet point, you need to de-risk your service from cascading failures and from queries of death. Cascading failures, in my book, they fall in the same category, even though they're totally different things. So query of death is when a certain query kills your service. So let's say you divide by something, and a certain kind of query causes you to divide by 0. So, well, you fail, that's okay, that query fails, you move on. But if this query is being retried, worst case scenario is not retried by the user. Worst case scenario, you have some pipeline that would actually keep retrying this query because it has to succeed for the pipeline to move forward. Then once you see this query once in the input stream, your service is just stopped. It's crash looping. It tries, it fails, it tries again. This will be page and alert, of course, you'll be woken up at night, but that's kind of ugly. So ideally, you want to find all these issues during load testing phase. And the cascading failure is a more extreme example. It's when something like this results in your service being temporarily unavailable, but then other services depend on it. My personal nightmare is when it happens in the JVM world, so that in theory, your service should be able to get back to up and running automatically, but in practice, it takes half a minute to warm up, and autoscaling doesn't know what to do. All the nodes are up and running. You should be fine, but you're not. And your queue is growing, and then the queue is overflowing, and bad things happen. So as an architect, this is what I'll be looking at if I'm doing performance testing, or if I'm overseeing performance testing of a production service, or a soon-to-be production service. The numbers we see in the results of load tests, they actually affect the company's trajectory. They really affect what the company does, what the engineering part of the organization would do. Notable examples would be the build versus buy decision. Sometimes you can claim that you can build something, or you can pay some other company to give it to you as a service. This decision would literally affect what multiple teams could be working on for the next year or so. And this decision cannot be made lightly based on some ballpark estimates back of the envelope calculations. That's where proper load testing helps. Most companies these days use Docker, but in certain points you would say, hey, I'm better off without Docker. Well, justify it. If you need to justify it, that's the part where I would need some load test. To cloud or not to cloud, or I think that's the way I like to put it. Most people do use the cloud today, but then you would have the choice between pure cloud, hybrid cloud, or self-hosted. That's DHH, the founder of 37 Signals, has an awesome series of blog posts about leaving the cloud. They claim to save $1.3, $1.6 million per year in cloud costs. So I think the cloudification looks complete to me, as I kind of imagined many years ago. So the cloud companies have reached the point where they lure you in, and then you get locked into their technologies, and then they start overcharging you, and then you know for a fact you can save a lot, but it's too expensive to switch. So I cannot predict the future. I would personally hope that we would see more on-prem solutions. I was just speaking with a friend recently. They just made the decision last year to migrate fully to self-hosted Hetzner's Kubernetes there. I endorse it. It's a good idea. It's cheaper too. So the bottom line is the decision along these lines. It requires load testing. It requires proper numbers. In my experience, Docker does not add much slowness, so that's okay. But also in my experience, for example, service mesh. So the service mesh gives you in the order of 4.5 milliseconds extra for each request, latency-wise. And it takes, I think it requires 0.3 CPU per 1K RPS. So if your service has 3000 RPS, the full 1.0, full 1 CPU is gone just for routing on the I think Istio level. So depending on how business critical your service is, this could be negligible or this could be huge. So I think this is something to be aware of. Another growing theme, I can talk about this for hours, but I just mentioned this briefly. So the theme of the past couple of years is breaking down monoliths to microservices. We've all been there. The current stage of evolution of this process in the industry is this idea of zero trust. So we have microservices, and how do we know my peer microservice was not hacked? Why don't I? How can I trust the messages coming from it? I need to redo all the authentication checks, like confirm checksums and SSH, MD5, OpenSSH checks or whatnot, because I cannot trust this service. I think it's a terrible idea. It adds too much latency and it weighs too much CPU. If you care about the planet in terms of not warming it up and saving polar bears, you should probably not do zero trust. That's my official opinion. Not representing any company, just me thinking. So the proper solution is what is called security perimeters. When you know which services are chatty to one another and you put them together into some isolated sandbox where they trust each other by design, so they don't need to check each other's credentials for every single request. There are tons of things I can probably skip over them in the interest of time. So sometimes your service can run better on ARMs than on AMD 64. BBFs are taken off. It's a whole different topic. Kernel level modules, like WASM for running binary code in the browser. You can run binary code in the kernel with no user space switches, and it can do a lot of you can design an application to do lots of logic there, not just routing. Although it started with routing, but you can actually parse JSONs and respond with JSONs, not live in the kernel space, which may be a lot faster in many cases. This goes all the way down to selecting vendors for hardware. I've seen stories, they're confidential. Nobody will tell you publicly which hard drive provider gives you better hard drives, but I've seen cases where the tech lead just says, for this particular task, in this particular rack, we're gonna say yes to those hard drives and no to those hard drives. We know we have fewer error rates and the performance is faster, is higher. This happens. And if you don't have load tests, it would happen painfully. On the lower level, I've literally seen people say that in order to have the best performance for our system, the best we can do for the database is buy a supercomputer, as in industry-grade supercomputer. It's going to cost us literally over 100 grand, but it's going to make us scale vertically just enough to last for the next 2 years. Again, you would not know this until you try. For super low latency, I would go all the way to FPGAs. High-frequency traders use FPGAs and do computations at the time the network packet hits your network card. So by the time the first digit of the price or the third digit of the price is there, it starts applying the model. By the time the last digit is there, the packet to buy is already prepared. It's just a single bit flip to send it. You probably won't do it unless you are in the HFT space, but it's just important to think about this. Recap on goals, on the objectives of load testing. I hope I convinced you that it's far, far deeper than just measuring big QPS figures. And if that's exactly why I'm always skeptical when someone tells me I'm going to run some load testing, give me 3 days, I'll configure Apache Bench or GHC or K6. Sorry, I don't buy that. they can be helpful to compare two implementations locally on like an A/B test, but that's not helpful for the proper load test. To the final part. When to load test, when to not load test. I'll first play some devil's advocate here. So it's a fairly recurring pattern when some engineer claims they would like to invest time into load testing their code because it's important, or so they say. Then their lead manager or whoever else tells them, we don't have time for that, we got to ship features, go ahead and do your work. The engineer is leaving unhappily. That's not a good solution for all of us. I would first of all say that even though I'm on the engineer side, in these situations, the engineer is often wrong. It is often not justifiable to spend time to do proper load testing. If we know for a fact the service is not business critical, which in the world of microservices is true for most services, you break the monolith so that most microservices can fail independently without affecting other parts of the system. So that's okay for your service to fail. So you don't need to test it seriously. And second, because when an engineer talks like this, but a manager or the tech lead, or I in this case, when I see the person who would like to run the load test is not thinking far beyond the PQBS level, I will have to talk them out of this idea, because then even if we do need a load test for real, we would need to redo the job of this person to do the proper load testing exercise. So in many cases, I would actually, even though I'm always on the engineer side, in many cases, I would agree with the idea to not do load tests. My litmus test is, remember a couple of minutes ago, more like 20 minutes ago, I tried to play the role of the SRE who's going to support your service. So the good litmus test for whether you need to do proper performance testing is, do you need proper SRE support? Would you need to be the team that is talking to me like I'm the SRE? Would you need to convince me to carry your pager because your service is so critical and you want to sleep overnight and your team does not have over the globe members, so that at least one of you guys is not asleep? So if you do need SRE support, then probably you need some performance tests. If it's just a small microservice, it's probably an overkill to claim that you do need it. It's not like a one-to-one rule. It's just a good heuristic. So just don't get me wrong. I'm a huge fan of tests, but I also think many people do testing wrong. Not too long ago, I've literally been reviewing a pull request where the person told me at some point, hey, don't merge it yet. I need to add a test here. So they spent another couple hours. They built the test passed, but the code didn't work. So that's a normal occurrence in my life. To me, it's a proof that this test was, well, first of all, this test was useless. But more importantly, this test and the time it took to write this test was useless. But second, on a higher level, the whole process is kind of broken. I'm okay with tests, but they should test the real thing. And with load testing is doubly so. You gotta be careful. Now, the silver lining, it's in certain situations, it's rather easy to advocate for load testing. I don't want to repeat myself. We covered most of this before. Basically, if you have a big decision to make company-wide, if this decision will have lasting consequences, then yes, by all means, do load test. If you would need to run this test again and again, a month from now, a quarter from now, do write it. If you believe that your service might be the bottleneck, do write it. And I'm gonna play a bit of a strange role. I don't always do it. I don't often do it, but now I feel like I have to. I'm going to play the role of a career coach. So advocating for load testing is actually a high-profile job, in the sense that it's a good one of the best actually ways for the almost senior or a bit over senior engineer to stand out. If your service needs a proper load test and the team doesn't quite see it, and you do, and if you're bored and you feel like your daily routine is not as interesting, that's actually one of the awesome ways to step up, one of the awesome ways to stand out. You need to tackle this task properly. It's a cross-functional, cross-team exercise. It's not that you convince your manager and you start coding for the next 3 weeks. But if you do take this task seriously, it's going to help your career, your team's career, your company, and overall, it's going to improve the world. So even though I'm strongly against what I call career-driven development, as in taking tasks not based on what is more impactful for the company, but based on what's going to help advance your career, this is one of the exceptions to this rule. If you feel like you need that, your team, your project needs a proper load test, and it's not there, and you know for a fact it should be there, and you can justify it, If no one else is doing it and you feel like you could be that person, by all means do it. It's going to give you more visibility to the higher up. You'll learn to speak in managerial / non-engineering language, non-implementation language. It's a good exercise. Take it. It's going to be fun. Extra slide. I kind of covered all this before about this partially unhealthy state. So the bottom line is I want to reiterate. And if someone argues against this and you feel like they're wrong, you can send them here or send them to me. I'll coach them. The point is, you do actually want to have this idea of a partially unhealthy state. You do not want, if it's a production critical service, you don't want to try to serve all the traffic. It's perfectly justifiable. It's actually encouraged to have some limiting mechanisms, either on the side of your service or on the side of its cloud configuration, or both. That's normal, that's healthy, because that's the way to avoid far more painful side effects. I'll not cover the top part of the slide, but I like the bottom bullet point. Don't be a ninja architect. Like there are ninja developers whose code just magically works, but then it doesn't, and nobody knows how to fix it. So if you can relate to the person who says, "Hey, look, my service is handling more capacity than planned, and it's in production. I'm awesome." You just wrote a bad service. The fact that it holds more traffic than planned is not something to be proud of. That's just strange. The far better solution is to say, hey, we have semi-planned outage because somehow our traffic has grown beyond the numbers we anticipated. It's okay. We're going to fix it tomorrow morning. Right now, some users are experiencing slowness or whatnot, but the whole company is running just fine. That's a healthy state of mind. That's a healthy state of affairs. That's normal. That's how it should be. I just want to stress it. And one more extra slide. Again, I think I covered this in the episode about coroutines. If you are entering this high performance territory, if you are already at the point where your objective is to ship a service that is performant, and somehow it's not performant enough, one of the most popular failure modes is if you're not CPU bound. You do want to load your CPUs. If your CPUs are not loaded, you're doing something wrong. These wrong things most frequently, they would either have to do with input and output parsing, marshalling, and whatnot, or they would have to do with poor multi-threading, poor synchronization and lock contention. And if you find yourself in either situation, well, you better fix that, because adding machines to a critical service that is not loading the CPU to a healthy degree, that just feels wrong to me as an engineer, as an architect. I would keep asking you why. I would look myself. I'll do more profiling. That's just not how it should be. If you have a big, highly loaded service and it's not loading the CPU more than 10, 15, 20%, it is totally broken. If it's loading CPU like only 40%, it's semi-broken. You should be able to show that it's loaded 60, 70, 80%. If your issue is with parsing the inputs, it's actually perfectly fine to claim that your service is high performance and you need inputs prepackaged in a certain way, down to binary format if you want. So your service itself is CPU at 90% usage because your inputs are well packaged for you, and you have a frontend service next to your service. Sorry. So your service accepts the data in a binary packed format to quickly serve the requests. That's how you get to peak throughput. And then there's another service also built by you, the only job of which is to get requests from HTTP, JSON, gRPC, and whatnot, and pack them for you in a binary string form. That's perfectly fine. That's okay. That's how it should be. I forgot to mention client libraries here. You would also ship client libraries for other services so that they don't make requests to you. They make local host the client library that is maintained by you. So you can change protocol behind the scenes as your convenience. So yeah, the bottom line of this slide is you do want to be CPU bound. If you're not, something's broken. Again, if someone argues that your service should do a lot of heavy lifting, plus parsing ugly JSONs or XMLs, and that's where you spend most of your time, and that's how it should be, this person is wrong. Send them to me. I'll teach them the right way. I think that's the last slide. To recap, load testing is not just how much requests per second can my service handle. It's far more than that. At the very least, level 0 thinking is peak RPS. Level 1 thinking is peak RPS plus latency and the diagram between these two. Proper thinking, SLAs, SLOs, your agreement with the DevOps team, proper monitoring, partial unhealthiness and refusing to serve requests beyond capacity, etc., etc. Sorry, couldn't mute quickly. I didn't speak for so long for a while. Bullet point 2, load testing is a hard problem. And if you think about it from the company-wide technological perspective, it's not just about the numbers. It's not just about the numbers of your service. It's about how the service fits the overall architecture. And that's what may change years into the future. So if your service is something others depend on, you better justify it for yourself and for the broader team, how much traffic it can and should handle. Essential at major forks, such as build or buy, cloud decision, service mesh, zero trust, and the like. And of course, load testing is important, both technologically, as it's an important, useful, and fun problem, and I'm playing the uncomfortable role of a career coach. It's also important career-wise. It's a high-value task, and if you find yourself looking for the big challenge in your team, if your service is critical and it may benefit from load testing, don't overdo it, but at least try. That may well be your next interesting thing and your next step up in your career, in this company, or overall. That is indeed it. I'm going to leave this slide. Thank you. Happy to answer any questions.
Hey, I have a question. What is the best time to do the load testing? Is it like after the service is deployed and then we get some amount of traffic, or before the service is deployed where we can expect a certain number of traffic? And that is all expectations. I'm not sure whether it's actually going to happen. What is the best time to do a load test?
That's a good question. Best time as in best time to justify starting doing that?
Yeah.
Well, so most services don't have load tests. And most services can live without load tests, in which case, speaking statistically, in most cases, you will load test the service that already exists. So, and it may be the best time for most services again, because otherwise it's a waste of time. If the service is critical, if it's expensive, if many depend on it, then yeah, the sooner you start, the better. I can totally see the idea of test-driven development taken further down to load testing. I've seen cases, I've written it myself with my own hands, that you have some component that just need to respond with something non-trivial but mockable. And I've mocked it as a standalone component, and I've tested the whole system with this component mocked, just to argue that, hey, this is your peak number. You cannot possibly get to this number, but if it is this high, that's how your whole system behaves. Now let's talk from there. And yes, in many cases, if it's a critical service, I believe it's a correct solution.
Makes sense. Thank you. My second question is on one of the slides, I think it's page 9, you said priorities today.
9?
Page 9. Yeah, the last point called architecture. What should our priorities be today so that we don't regret them 5 years later? I guess my question is, how do you know these, and how do you determine that these are priorities? By is it like load testing may give you only like symptoms, or your latency is high, or your processing or CPU power is high. Like those are symptoms of a major architecture issue. May or may not be, but I'm thinking like that could be an architecture issue. But to isolate from that symptom to the actual root cause, can we do that with load testing?
Well, if you found the issue with load testing, you probably started load testing too late. My main message here is that if you look at the whole industry of building software, that's still a bit of an art, not craft, at the highest level. So at the highest level possible, decisions on how to ship stuff are mostly made by consensus of a couple of people who are presumably experienced. So we don't have proper metrics because we have not been solving this problem in the industry for so many years. It's not like building pyramids. It's not like architecture of brick and mortar stuff. So the point here is that, I guess what I tried to convey, is that in order to not look back 5 years later and say, hey, if only we knew back then this would be a bottleneck, we would have packaged things differently. In order to not end up there, you need to know for the critical components how far up can they scale, and at which point they would need to be redesigned, restructured, rethought. So in this case, it's only applicable for important components that many other pieces depend on, like your key core database, your core data warehouse, your auth system, authentication authorization, your core data database with presumably tons of read replicas and just maybe one write replica. At some point, you would realize that, hey, our bottleneck is, let's say, reads from Cassandra. The decision to retire this is a high-level architectural decision. Ideally, you would like to know beforehand that with a projected traffic growth, we would have to do it, let's say, within the next 18 months. So if the proper solution would take us half a year to build, we should not delay it too far. And for these numbers to be tangible, not just best guesses, but real numbers, you would load test this particular piece to find the seeded, the headroom. That's the point I was trying to make. I'm not sure I made it well. So thank you for the question. Is it making sense?
It makes sense. Thank you so much.
I think I failed at making this an under an hour episode. I believe we have crossed the hour mark. I don't know yet, but I think we did. So shall we? If you have more questions, I'm more than happy to answer.
All right, I'll ask one more. Like many times in real world production system, you may not get a week n minus, current day minus n weeks of data. And most probable what happens is we just make up numbers. It could be because of PII, or it could be whatever reasons. How do you get better at those makeup data, which is as closest to production? Like I usually take a view of a DB or write a certain data after removing the PII and other details to an S3 bucket, and then start reprocessing it. But that also requires like a bunch of approvals and other things. How efficient, or how can I get better at this? Is there a standard that companies follow? Is there a way that I can get data as well as keep the freshness of the data? Like I don't care like 1 year ago what came, but I want like a more closer look at what happened 2 weeks ago when there was like a peak traffic.
That's multiple questions in one. So PII realistically is not an issue for this sort of problems, because there are too many ways to fake PII data in so that they look real but they are fake. There are services, they're open source, that just replace the names by some random John Doe in the way that makes sense. So this issue does not exist in my mind. If you have the data, but it's too dense with PII, you need a small sub-project that would copy this data, replacing PII by something fake, and that's a simple project. You can have a team in the company that would solve it within single-digit days. So that's not an issue in my mind. Data locality could be an issue. If you suddenly have users from Europe more frequently than from America, and you can only store their data in Europe, yeah, I'm not saying it's easy. There could be issues, but PII itself is quite a local problem in my book. Now, for capacity planning, that's a painful topic because I'm sort of divided. When I help people with interviews, which is part of my job right now, like part of my life, I'm a strong advocate for not doing capacity planning because I think it's useless. It's a waste of time when you're speaking with someone. It really doesn't affect your design much if you're off by an order of magnitude. So when you're trying to estimate how many users would your system have, chances are you can just ignore capacity estimates and you'll be fine. But at the same time, in the real life, if it's not the interview, in the real life, you actually need to answer, do I need 15 machines or 15 machines? And you cannot possibly know how much higher traffic would be in half a year. The short answer is, well, first of all, stay conservative. You just overestimate, and that's fine. Second, you would often have people. I don't think it's a secret what I would say right now. One of the criteria for hiring people as top level SREs, DevOps, and whatnot, one of the criteria, one of the objectives is to hire the people who have seen it before in real companies. So they would have some real life experience. We cannot really tell them, hey, we would like you to join because you know the numbers from that service and that company. That's not what is allowed to be done. But we know for a fact that if this person has a 20 years career, of which 10 years there was like Amazon and then 5 years of Netflix, chances are these people know approximately how traffic patterns look like. They know what to plan for, they know the pattern of outages, possible problems, and that's pretty much what they paid for, this experience and how to apply this in the real life. When it comes to proper capacity planning, honestly, I don't have a good answer. I have never done it myself, but I think in practice, at the very least, you can. So yeah, another open secret in the industry is that it's actually not a secret. People don't hide this in a way. So on the one hand, if it's a super secretive startup, like you cannot learn today what's the traffic of some internal component of ChatGPT. That's top secret. That's commercial secret. But if you talk to SREs from Netflix or Twitch about the numbers, hey, how much more views do you get at peak hours? What about, let's say, if it's a world finals of some sport? You can get these answers. It's not a secret. Engineers, like no reasonable company would instruct engineers to never share this sort of insights, and no reasonable company would make people terminate their contracts if they share this. It's a closed world, and people, like closed as in it's tightly connected world, and people know this stuff, and I think it's okay. I don't see anything wrong with that. So chances are, in any reasonable company, you would have somebody within 1 or 2 handshakes who could just help you and who would know enough semi-internal data that you could not talk about this publicly, but it would not be such a big secret so that you would not be flying blind. That's my understanding so far.
That makes sense. Thank you so much. I noticed one thing that you have explained the process of load testing, but you have not carefully avoided any kind of libraries or anything that is outside. Any recommendations you have? The 3 things I can think of is like Locust or JMeter or Fiddler.
I didn't really avoid them because I didn't want to say any names. I just don't have much experience. I think JMeter is I don't like the way it's robust. Let's put it this way. It's claimed to be robust. It's more robust than Apache Bench, but it's not robust in the directions I endorse. Sincerely, like honestly, my personal opinion, I write my own tests. For a good engineer, sending a proper pattern of random data that fits certain criteria, that's a 2 days exercise. I don't think it's. Well, I have fun doing that. I also know I need to keep myself in shape, right? And I never ever anyone has told me I'm doing the wrong thing by spending 2-3 days of my life, of my paid engineering work, writing my own custom load test.
Fair enough.
I'm not saying I recommend this, even though to be honest I do. But it's a personal decision. It's a matter of team dynamics. Maybe your manager would hate you if you do something yourself, for which you can use an open source project. In my experience, on most teams that I was part of, either it's super trivial to test and the question does not even arise, or you quickly run into limitations of these tools, and even the manager himself or herself would say, yeah, maybe you're right, writing something from scratch was a good idea. And then I would do a totally politically incorrect thing. I would write it over the weekend, and I would say on Monday, hey, here's what I did. That's not what I recommend doing. That's not the proper way in the modern world. It's just how I am, and it helps me be me, and I enjoy it.
That makes sense. Thank you, Dima.
Thank you for awesome questions. My pleasure. Thank you, Fox, for making this what I hope is a successful event. Glad to be resuming this. Hope to speak more frequently, more regularly.
Thank you for explaining and organizing this. I really appreciate it. Thank you so much.
Talk to you soon.